From the continuation of the previous video, I think there was a glitch from the network when uploading it to YouTube. So I'll continue right from example 4. Example 4 says that prove by mathematical induction that I1 square plus 2 square plus 3 square plus 4 square plus all the way plus n square is equals to n open bracket n plus 1 close bracket open bracket 2n plus 1 all over 6. Now let's solve this solution. Now the first step in mathematical induction is that show that n is equals to 1. Now let's go n. First step 1, prove that n equals to 1. Now let's go here is equals to 1. Now let's show it here now. That is, since we have n open bracket n plus 1 2n plus 1 all over 6, I have to show that this is equals to 1. This must be equals to 1. Now let's try it by saying 1 open bracket 1 plus 1 2 1 plus 1 all over 6. This is going to give us 2 open bracket 3 all over 2 into 1 all over 6. 2 into 1 2 into 6 3 cancels 3. We are left with 1. That is the first step is true. Now moving to the second step 2 states that n equals to k. Now I want to show that n is equals to k. Now let's start by saying that 1 square plus 2 square plus 3 square plus 4 square plus all the way plus plus n raised to power 2. It must be k plus k raised to power 2 equals to k open bracket k plus 1 2k plus 1. That is, then when you see n you put k 6. And this is the second step achieved. First step achieved, second step achieved. Now going to the third step 3, which says that assume that k equals to k plus 1. That is, anywhere you see k you put k plus 1. Now let's start by saying 1 square plus 2 square plus 3 square plus 4 square plus all the way plus k square. As I said, you first write this complete thing down, then you use this k, that is k plus 1 square. Substitute k into this k, then add it. Don't touch this, please don't touch it. Just do that. Then it's equals to, anyway you see k, put k plus 1 open bracket k plus 1. That is, if you put k into it, that will be k plus 1 plus this one. That's it. Plus 1 open bracket 2k plus 1 all over 6. Now in doing this, we are going to have since this is equals to this, therefore this we are going to substitute this into this. So we are going to have k open bracket k plus 1 2k plus 1 all over 6 plus k plus 1 raised to power 2 equals to k plus 1 still have our brackets into, that's k plus 2 open bracket. Simplifying this, we are going to have 2k plus 3. We're going to have 2k plus 3. We're going to have 2k plus 3 all over 6. Now if you simplify this both side, you are going to have your LHS equals to RHS. Try it and you'll get it. Okay, just 3 steps, that's all. Just simplify the left hand side, it must give you the right hand side. It's gonna give you that. Okay, now moving to example 5. Prove by mathematical induction that a raised power n minus 1 is a multiple of 7. Let's start solution. Let's try. Don't forget our first step. Step 1. Assume that n equals to 1. Let's put it into it. That a raised power 1 minus 1 gives us 7. Therefore, step 1 is true. Now let's go for step 2. Step 2 says n equals to k. That is, anywhere you see n, put k into it. Anywhere you see n, put k into it. Now we're going to have a raised power k minus 1. Since the set is a multiple of 7, therefore let's just add that 7 equals to 7p. Now if the set is a multiple of 10, it's still going to be a raised power k minus 1 equals to 10p. Let's get this part straight. The set is a multiple of 15, it will be a raised to power k, a raised power k minus 1 equals to what? If you say multiple of 15, that's 15p. Let's not forget. Now what we're going to do right here is to make the 8 raised to power k subject of the formula. That's 8 raised to power k equals to 7p plus 1. Now moving to step 3. Principle of mathematical induction is not that hard. Just to this first and the second step I've done now. Going through the second step and the third step. Step 3. Step 3 is gonna give us that's to prove that anyway you see k, put k plus 1. That's the third step. Anyway, anytime. Now we are substituting k into a raised to power k equals to 7p plus 1. Now what do we have here? This k here, put k plus 1 into that. A raised to power k plus 1 equals to 7p plus 1. Now through our law of indices, we're going to have it divided, separated. That will be a raised to power k dot a raised to power 1 equals to 7 that would be 8. Wait, there's an amendment. There should be an amendment here. I made a mistake. We're not going to use this. We're supposed to use the question itself, that is a raised power n minus 1. That will be 8. Since we're using a raised power n minus 1, that will be 8 raised to power k plus 1 minus 1. That is, anywhere you see n, you put k plus 1. So as you know that n equals to k, therefore either n equals to k plus 1 or k equals to k plus 1, they are still all same thing. Let's not forget it. But yeah, n, anyway you see k, anyway you see n, you put k plus 1. Now we have 8k plus 1 minus 1. Now let's use law of indices to separate. That will be a raised to power k dot 8 minus 1. Now since we have 8k founded here, it's 8k and I'm on you. Oh, let's continue. Since we have 8k that we have founded here, now let's now put it into the equation by saying 8 open bracket. The 8k is 7p plus 1 minus 1. That's it. Now if 8 times 7, that will give us 56p. That's 56p plus 8 minus 1. That gives us 56p plus 7. Now the question said, prove by mathematical induction that a raised power n minus 1 is a multiple of 7. Now our final answer judges us and qualifies us to say that our answer here will be 7 open bracket 8p plus 1. That is, the whole equation 8 raised power n minus 1 is a multiple of 7. Therefore, a raised to the power k plus 1, no, a raised to the power k plus 1 minus 1 is equals to 7 8p plus 7. That is a multiple of 7. Thank you for this. Now let's move to the question example 6. Prove by mathematical induction that 1 raised power 3 plus 1 raised to power plus 2 raised power 3 plus 2 raised power 3 plus 4 raised power 3 plus n raised power 3. I think I've done something related to this. Oh, they are different. Now let's continue. Solution. Well, you can pause the video to just solve this question and see how far you've learned and how I'm teaching this, whether it's good or whether it's entering. Well, while pausing, well, let me just solve while you pause. Now, the first step stays step 1. Prove that n is equals to 1. N is 1 here now. By the time we substitute 1 into this, it must give us 1. If it doesn't give you 1, either you are wrong or the question is wrong. Now let's try it by saying the question says n raised power 2, n plus 1 raised power 2 all over 4. Now what do we have here now? We have 1 raised power 2 open bracket 1 plus 1 raised power 2 all over 4. That is, we have 2 raised power 2 over 4. That gives us, if 2 raised power 2 is about 4 over 4, that gives us 1. Correct. Now step 2 states that when n equals to k, that is, anywhere you see n, you put k. Now let's start by saying 1 raised power 3 plus 2 raised power 3 plus 3 raised power 3 plus 4 raised power 3 plus all the way plus k raised power 3 equals to k raised power 2 open bracket k plus 1 raised power 2 all over 4. Now the third step says step 3. That is, anywhere you see k plus 1, k equals to k plus 1. Now can you just say, like, it hasn't even taken me up to 2 minutes. I've done step 1 and step 2. It's not really hard as I think it is. Now let's go by saying anywhere we see k, we put k plus 1. Let's go. I raised to power 3 plus 2, 1 raised to power 3 plus 2 raised to power 3 plus 3 raised to power 3 plus 4 raised to power 3 plus all the way plus k raised to power 3 plus k plus 1 raised to power 3. Let's not forget, I keep on saying that you leave it and add it. Add plus then k raised to power 3 raised to k plus 1 raised to the power of k. Now let's continue. Then equals to k plus 1 raised to power 2 open bracket k plus 1 raised to power 2 all over 4. Now since this is same thing as this, therefore this is equals to this. Let's substitute it into it. That is, we're going to have k raised to power 2 open bracket k plus 1 square all over 4 plus k plus 1 raised to power 3 is equals to k plus 1 raised to power 2 raised to power 2 open bracket k plus 2 raised to power 2 all over 4. Now I'm not going to go further to solving this. Just solve it yourself and you see that the left hand side will give you the right hand side. That's it. The left hand side should surely be equals to the right hand side. And so as hard as I think it is, well, when solving this either in an exam or anything, you have to solve to your final answer to show that this is properly equals to this. But I cannot give you hints when you want to solve it. Instead of confusing yourself, you can just multiply the both sides by 4 to cancel the denominators. That's just a quick hint I just give you now. Now let's move to the last question of the day. Prove by mathematical induction that 9 raised to power n minus 1 is a multiple of 8 for all positive integers of n. Wow. Now Now let's go start by saying solution. Don't forget your step 1. Mathematical induction is basically simple because of just has 3 steps. It just looks like a puzzle. First step, n equals to 1. Second step, n equals to k. Third step, n equals to k. K equals to k plus 1. Now let's start with first step. First step says that what? Step 1. That is n equals to 1. That is 9 raised to power 1 minus 1 equals to 8. That is a multiple of 8. Yeah, correct. Now step 2 states that what? N equals to k. Now let's start by saying 9 raised to power k minus 1 equals to what? Since the multiple of it will be 8p, as I said earlier above. Now let's make 9 raised to power k the subject of the formula. 9 raised to power k equals to 8p plus 1. That's all for step 2. Now step 3, that is k equals to k plus 1. You know, you see k, put k plus 1. Now let's go. We have what? 9 raised to power n minus 1 from the question. Now let's change the n to k, since we know that n equals to k plus 1. So let's not stress ourselves, and let's change that to be 9 raised to power k plus 1 minus 1. Using our law of indices, we can break this down to 9 raised to power k dot 9 minus 1. Since you have founded 9 raised to power k here, we can also say 9 open brackets 8p plus 1. That's our 9 raised to power k minus 1. That gives us what? That will be what? 9 times 8 will give us 72p. P plus what? 72p plus 9 minus 1. That gives us what? Equals to what? 72p plus 8. They said what? Prove by mathematical induction that 9 raised to power n minus 1 is a multiple of 8 for all positive integers of n. Now it's a multiple of 8. Now let's now factorize this to say what? 8 will enter this 9p plus 1. Therefore 9 raised to power k plus 1 is a multiple of 8. 9p plus 1. Therefore it's a multiple of 8. Period. I hope I've been able to justify the glitch in the previous video in this video, and I hope you were able to understand. Thanks for watching. Please like and subscribe to my channel to enjoy more from me. Thanks for watching.